Welcome to Melak Online tutorial. Now before us, we're looking at the verification of the refractive index of a glass prism. And here is the formula that n equals sine, then in open brackets, minimum deviation plus the refracting angle of the prism all over 2, close bracket, all over sine the refracting angle of the prism all over 2. Okay, now to bring this formula to its simplest form, it implies this is just according to Snell's law that the refractive index equals to what? Psi I all over what? Sine R. Okay, now yi is the angle of incident and R is the refractive what? Angle. Okay, now let us now start by bringing out those expressions for the incident angle and the refracting angle. Okay, so it implies that I here equals to all this expression, then I here equals to A all over 2. So how do we derive all these expressions from this diagram? Okay, now let's start with, now this is the normal. Okay, all right, because the normal is actually that part or that point which the incident ray enters into the prism and leaves the prism. Okay, all right, and that is why it's always at 90 degree. Okay, now to the prism. Now the incident ray lands at the normal, forming an angle. This is the incident angle. Now it's actually refracted. Okay, so the angle here, now this is actually the normal. Okay, so this angle here is called the refracted what? Angle. Okay, because there is a sort of refraction. Now it now travels this pattern. On getting here, that's as it tends to leave the prism, now it emerges out here, now forming another angle here. Now this is called the emergent what? Angle. All right, and this prism is an equilateral prism, which implies that this is 60 degree from equilateral triangle. Now this is 60 degree and this is what? 60 degree. Okay, now the angle, the incident angle here is always equals to the emergent angle, which means we can write this also as I. Okay, now let's make this one just I1, which is the angle of incident, and I2, which is the incident that emerged after refraction. Okay, all right. So in this case now, if we also presume that the incident ray is coming towards this part, towards the emergent ray here, it also follows the same pattern and come out here. All right, which also implies that as it comes here, this one also is formed. That is the refracting angle. All right, so let us make this one 1 and let us make this one what? 2. Okay, all right, now here we go. Now for the incident ray, we presume that normally it should actually move this way. Okay, and for this emergent ray also, it meant to actually go this way. All right, now this angle here is the deviation, all right, between the incident and the refracting the refraction, and here the same thing. Okay, now let us make this one D1 and this one what? D2. Okay, all right, so at this point here, this angle here is what we call the minimum deviation. All right, that's the minimum deviation. All right, so and the minimum actual deviation is the smallest deviation produced by the prism. Now here we will now start deriving the expression for incident angle and the refractive angle. All right, now let us take a look at this d1, d2. Now the minimum deviation dm is equals to d1 plus what, d2. Now according to a geometric law, that the external angle equals to the two opposite interior angle, that is the sum of the two opposite interior angle. So dm, which is the minimum deviation, is equals to the sum of the two angles, interior angles here. Okay, in the same vein here, r1 and r2 will be equals to, here this is the refracting angle, which is what, c, 60 here. Okay, all right, so here we have that a will be equals to r1 plus what, r2. Now, and because this is an equilateral triangle, it implies that the refractive angle from this end, r1 and r2, will be the same. So we end up having here, since they are the same, you have what, 2r. Okay, so we can see here that a equals to 2r, and making r the solid of formula, we end up having that r equals what, a all over what, 2. So it implies that we've gotten the expression for what, for r. Okay, here is it. Now let us now go for I. All right, now for I, now let us consider something here. Let us consider this angle. Now if you look at it now, you see that it's this angle formed here is the same thing as the angle formed here. All right, now let us recall that if you have this like this angle is always equals to this what, angle. All right, so which implies here that I1 equals d1 plus what, r1. Okay, so in the same vein also here, I2 will also be equal to this same angle here, the sum of d2 plus what, r2. All right, now adding the two together, now let us take note that this angle here is equals to this angle. All right, so we can end up saying this is 2i now plus, now let us come back here, that d1 plus d2 equals what, dm, then plus, then r1 plus r2 equals a from this equation here. All right, so to this end, our a here, so here we have 2i equals what, dm plus what, sorry, r1 plus r2 equals what, 2r, which is a, yes. All right, so there we have it, a. Now dividing both sides by 2, so our I equals what, dm plus a all over 2. All right, now that we've gotten for that of r and gotten that of I, so we can now say that refractive index equals what, sin I all over sin r, which will now give us sin into dm plus a all over 2 all over sin a all over 2. All right, as simple as that. Now let us solve this question. It says study the ray diagram below and use it to answer the question below, the questions below. Okay, now we are told to calculate the value of PQR, the refractive index of the prism, the value of E, and the total deviation. Now looking at this, now this is the incident angle. Now if you probably watch the verification of the refractive index of a glass prism, I actually explain all this. So here you have the incident ray, the incident angle, and this is the emergent what angle. All right. For us to calculate for P, Q, and R, now let's just take note of this, that this angle here, angle from here, is equal to the sum of these two angles at this end. Okay, and take note that opposite angle are what? Opposite vertical angle are what? Equal. So which implies that for number one, let's say that 45 now equals to 20 plus what? P. Alright, because 45 is the angle 45 is equal to the sum of 20 and P. Alright, to this end we can have it that P equals to, making a P is a formula, we have 45 minus 20, which will give us 25 degrees. Okay, and Q. Now for us to find the value of Q, now let us take note that P and R is equal to what? 60. Okay, so P plus R equals what? 60. Now, and that's because 60, which is an external angle, is equal to the sum of two interior opposite what? Angle. Okay, and sorry, it is R. So, and P actually is 25, so plug in 25 here. Now plus R equals what? 60. Then our R will then become 60 minus 25. Now this should give us 5. This one made a 5 here. So our R equals to 35 degree. Okay, now to this end here, our Q. Now looking at this triangle here. Now some of angles in a triangle must be equal to what? 180. So to this end we can say that P plus R plus Q equals what? 180. So and our P is given as 25, our R is given as 35, and our Q is unknown, 180. So when we add this together, it should be 10, it will be 60 plus Q equals 180. So our Q will now be 180 minus 60, which is what? 120. Okay, all right, and that is that. Now for us to find the refractive index of the prism. Okay, now the refractive index of the prism, now, which is N equals to sine I all over sine R. Okay, now to this end, what is sine R and what is sine R? Sine I here is 45, so which is sine 45, then all over sine R, which is here, that is the refractive angle, and our P here is our P is 25. That'll be sine 25. Now punching our calculator here, we tend to have, so we have that N, the refractive index of the prism, will give us 1.673, and that is after sine 45 has given us this value, sine 25 has given us, and by dividing we have this. So the next one is number 3, and this is number 2. Now for the next one, we are asked to find the value of the emergent angle. Okay, now for the emergent angle here, take note that N will now be equals to sine E all over sine R. Okay, all right, and where E is actually the emergent word. So here we have it. The refractive index of the prism is given as 1.673 and equals to sine E all over. Now sine R here will actually be the capital R here. Okay, so we can actually replace this one at capital R. Then an R here is giving us 35. So this is sine 35. Now cross multiplying, so finding sine 35 here. Now sine E will then give us 1.673, which is this, times, now sine 35 will give us 0.5736 approximately, then times, so let us multiply, times 1.673. Okay, so here we have equals 0.95959, then and so on. So here we have that E will now be the inverse of 0.9595, now which will give us the inverse sign. That will give us 73.7 approximately degree. Okay, all right, and that's that. Now we are to find the total deviation D. Now for us to find D here, let us take note that D is meant to be, which here is actually D1 and here is actually D2. So it meant to be D1 plus what? D2. Okay, now we know D1 but we don't know D2. Okay, and for us to get D2, let us consider this and this. Okay, which means that this angle is equal to this angle here. Okay, all right, so it also implies that for us to get this angle, it means that E minus R. Okay, let us take note that E, this angle here, equals to D2 plus R, which implies that D2 will now give us E minus R, which is, and we've gotten our E to be 73.7, then minus our R, which is 35, and this should give us 38.7. Okay, so to that end here, number 4, you can see that D equals to D1 plus what? D2. Okay, and D2 is giving us 38, and D1 is here 20, which is this 20, then plus 38.7, which will give us what? 58.7 degree. Now let us solve this question. We have to calculate the minimum deviation of a 60 degree triangular glass prism, and we are given that the refractive index of a glass is 1.5. all right, now let us recall that n equals sine into dm plus a all over 2 all over sine a all over 2. Okay, where dm is the minimum deviation, a is the refractive angle of the glass, and okay, that's all. And we are giving here that a equals to 60, which is the angle, the refracting angle of the glass, and I guess that is all we are asked to look for. dm, okay, and the refractive index of the glass equals 1.45. all right, plugging all these parameters into this and looking for dm. So here we have 1.5, then equals to sine, then into dm plus a, which is 60 all over 2, then all over, here we have that sine, our a, which is 60 divided by 2, give us what? 30. Okay, now and let us recall that sine 30 should give us 0.5. okay, So which we have here, we can say this 1.5 equals sine, now dm plus 60 all over 2, then all over 0.5. all right, 1.5 times 0.5 should give us 1.5 times 0.5. that is when we cross multiply, so we tend to have 0.75 equals sine, then dm plus 60 all over 20. Okay, now to this end, what we will now look for is the inverse of the sine inverse of 0.5. Please don't make the mistake of cross multiplying now, because the whole of what is in the bracket is a term allotted to what? Sine. So we have to find the inverse sine. So to this end, you can say this is dm plus 60 all over 2 equals to the inverse sine of 0.75. okay, and the inverse sine of that will give us 48.59. so here you have dm plus 60 all over 2 equals to 48.59. When we tend to cross multiply, so at this point when we cross multiply, we're multiplying 2 by both sides, we have that dm plus 60 equals, now 2 times our answer here will give us 97.181. so subtract 60 from both sides, answer minus 60, so we have that dm equals 37.18 degrees, so approximately 37.0 degree. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos. Sorry, this should be 2, not 0. Alright, now let us consider this question. We're told to calculate the refractive index of the material for the glass prism in the diagram. Now looking at this diagram, now we're only given this arrow, okay, now 60, 30. Now simply this just implies that this the incident ray now moves this way and emerge here. Now if I were to actually complete this, let's assume this is our normal, this one is also normal, okay. Alright, so it implies that this is our incident and this is our emergence, okay. And to this end, we can conclude that this is the minimum deviation here. This angle here is the minimum deviation, and here is our A, which is the refractive refracting angle of the prism. Okay, and we are told to find the refractive index. So which means that A equals sine to D plus A all over 2, then all over sine A all over 2. Now where our D is 30, so here we have that sine into this is 30 plus 60 all over 2, then all over sine A, which is 60 divided by 2. So to this end, we have n equals to sine. Now 30 plus 60 is 90, so this will be 90 divided by 2, which is what? 45. Okay, and the whole of this will give us what? 30, not sine, I mean not the whole of the, I mean 60 divided by 2 give us 30. So we have here sine 45 now all over sine 30. Alright, and sine 45 I'm sure should give us 0.7071 all over 0.5. okay, now punching our calculator here, 0.7071 divided by 0.5, that should give us 1.4142 approximately to 1.4. Alright, so that's the final answer. Now let us solve this. Now that a ray of light enters a prism of refracting angle 70 degree and is just totally internally reflected at the second face, calculate the original angle of incidence. Now this question looks logical. Now I want to draw the diagram to use to explain better. Now let's assume this is the prism. Okay, now let's say this is our normal. Now this is our normal. Okay, the incident ray. Okay, now went like this. Okay, now since the totally internally reflected, which means the emergent ray now passes this way, making the angle 90. Okay, so here we have, this is our eye. All right, so okay, now this is our R1 and this is our R2. Or now, since here is 90 and we are given that the refractive index of the glass, that is n, equals 1.4. Okay, now the first thing first here is, let us find R2, okay, which is the refracting angle for the emergent ray. Okay, so here we have that n equals sine E all over sine R2, which is this. Now after getting this, we will now look for this. Now take note that the refracting angle of the prism is 70, and let us take note that R1 plus R2 is 70, that is A. Okay, and our A is given as what? 70 from the question. So R1 plus R2 equals what? 70. Now let us keep note of this. Now from here we have 1.4 equals, now the whole of here is what? 90. So this is what? Sine 90 all over sine R2, and which is 1 all over what? R2. Okay, sorry, sine R2. So to this end, making sine R2 is well, the formula we have sine R2 equals 1 all over 1.4. So our R2 will now be the inverse of 1 all over 1.4. Okay, and that should give us so here R2 will give us 45.6 degree. Okay, now here 1 all over 1.5 will give us 0.7142, and the inverse of 0.712 will give us what? 45.6 degree. Now that we've gotten the value of R2, now let us come back to this equation here, that R1 plus R2 equals what? 70, and our R2 is 45.6, then R1 plus 45.6 equals 70. Then R1 will give us 70 minus 45.6, and that should give us 70 minus, answer will give us 24.4. Okay, so R1 now is 24.4 degree. Now take note, we have calculate the original angle of what? Incident. Now that we've calculated this, now let us come back that n equals what? Sine I, which is this one, all over sine R1, and the relative index of the glass or the prism is 1.4 equals sine I all over sine 24.4. Okay, all right, now, and this will give us sine I equals 1.4 times sine 24.4. Now sine 24.4 will give us, so here we have 1.4 times 0.4131. Okay, so sin I, then answer times 1.4 will give us 0.5783. So our I will now give us the inverse of 0.5783. So the inverse sign, our answer will give us, so I will give us 35.3. Alright, degree. Okay, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.